Okay, so today we are looking at, we've finished pretty much all of what we're going to cover this year on matrices. So now we're going to do in this chapter a little bit more application questions. So a little bit more of a scenario and, how we can work it out. So let's go through this one. So Freddie and George's store has sales promotion. 1 free cinema ticket is given to each DVD purchased, and 2 cinema tickets are given with the purchase of each game. The number of DVDs and games sold by Freddie and George are given in matrix S. So you can see here they've indicated matrix S down here. And the selling price of a DVD and a game together is with the number of tickets is also given in matrix P. So that's what that matrix P. So at the moment it says find the product SP. So what that means is you're going to get matrix S and multiply it by matrix P and interpret it. Now, because they haven't sort of said show your, it doesn't say show all the calculations, that's okay. So we can just go straight into our calculator and pop in that matrix. So matrix S, now remember order's important. So I need to put the S1 first. So I've got 7, 4, 5, and 6, and then I'm going to multiply it with P, which is 20, 1, 30, and 2, and press enter. And there's my solution. Okay, so we've done that. So let's write out what our answer is. So we've got 260, 280, 15, and 17. So what they want, the part of is that's easy. We could just times that on our calculator. But the important thing here is the interpret. So what you need to think about it, when we had, I'm just going to write S out here. I'm just going to write it a bit bigger, and then we had P. Okay, so S is a 2 by 2. Yes, and P is a 2 by 2. So what we said is, if we were thinking about it, yes, it's defined because the columns in S equal the rows in P. And remember our answer, so I'm just going to call my answer SP here. It would take that number there, that number of rows, and that number of columns. So it'll become a 2 by 2. So what you need to do is, the way you can work out what your answer is actually telling you is you look at this one. Because it takes the rows of S, so see here the rows, if you look at the rows of S, they are actually indicating Freddie and George. So if you look, your answer, this row, it's going to represent Freddie, and this row is representing George. Now, if you look, we took the columns of matrix P. Now, if you look at what the columns of matrix P were, they were the money and they were the tickets. Okay, so then if you look here, that's what columns we're going to have in our answer. We're going to have the money and the tickets. So if you look here, so here's our answer. So now I said, well, that's Freddie and that's George and that's money and that's tickets. So what do you think this matrix is showing you? So when you asked to interpret it, what do you think that's showing you now?
How much money it's going to cost for the tickets?
Well, I'm going to say it's going to show you how much money Freddie earned selling all his DVDs and games. Yes. So this row, it shows how, this matrix shows the total earning for Freddie and George, plus and the total tickets given away. Okay, so that's how you can do, because sometimes when you multiply these, you might not actually know what it's doing. So if you find out what the rows are actually representing, so I found out that this row represented something to do with Freddie, and this row was going to talk about something to do with George. Now, because I knew the first column was to do with money, well, I'm having a guess that's the total money that Fred earn, and then the other one is the money George. Now it makes sense because if you were timesing, remember when we manually times it, we would do row by column. So what would be happening there is you'd have 20, you'd have 7 times 20 plus 4 times 30. So can you see that's actually adding up all the money that he makes. So that's how, yes, we are right when we say 260 is because that would equal 260. That's how we know. All right, so that's where our application comes in. They'll ask you to interpret, to say what did you actually find. So let's have another look at this one. So Jackie and Peter's store has a special sales promotion. One free prize ticket is given to each drink purchase. 2 prize tickets are given with the purchase of each hamburger. The number of drinks and hamburgers sold by Peter, Jackie and Peter are given by S, and the selling price and the hamburger together with the number of tickets is given by P. So they once again want you to calculate S by P. So if I work that out here, so we're going to do S multiplied by P. And if I just label up, we know, so you don't have to because we can do it on our calculator, so we don't have to manually do it. But if we just have a look like this, so we know that's equal, but let's just make sure, all right, we're taking this one's rows and this one's columns. So this one's rows is Jackie and Peter, and this one's columns are money and ticket. So when we end up with our answer, we know that we're going to have Jackie and Peter, money and tickets. So we can just do it on the calculator again. So we'll go over here on my calculator and I'm going to type that one in. So 3, 10, 6 and 8 and multiplied by the other one. So 4, 1, 12 and 2. So press enter. So we end up with 132, 120 and 23 and 22. So interpret this one. Very similar to the question before. So what are we going to say? This tells us the total sales of, or, total earnings or whatever you want to say. Total sales of Jackie and Peter and the total tickets given away for each. So total tickets given away for Jackie and Peter because they are separated. It's not combined. So we want to say that we can see them separately. So I can say if I asked you how many tickets did Peter end up giving away, how many tickets did Peter give away? Just looking at the matrix. 22. And how much was the total earning of Jackie for this selling? 132. Good. So that's what we're doing. All right. Now we're moving on to what we're still going to be doing multiplying matrices. But now we're going to use these type of matrices that allow us to sum up a row, which means add up a particular rows or add up a certain column. So when we say summing, we mean add up. So let's have a look. So matrices can be used to store information. Matrix multiplication can allow key information from matrices to be extracted. So because it's more into computer coding, this is where they want to pull out one row all added up, or the computer wants to pull up one column all added up. So we need to use matrices, and we need to need to use it because it's like a coding, because the computer it wants to use numbers and figures. So if we use a row and column matrix, we can use for that. So if we want to add up a row, so maybe just above that, you might write add up rows, because that's what summing means. If you want to add up rows, you post multiply. So post multiply means multiply after with a column matrix of ones. So just to give you yourself an example, you would have, say, your matrix X, and then you're going to multiply it with a column matrix of ones. If you do that, that will add up the rows. This will add up these rows. Okay, so they'll add up the rows in your matrix before. So, because see how the post multiply are multiplied after. If you want to pre-multiply with, so if we're going to add up, this is add up the columns, we're going to pre-multiply. So that means multiply before with a row matrix of ones. So that means, so for example, we'd have a row matrix and we're going to multiply it by the matrix we've got. So that will allow me to add up the columns of that matrix. Sorry?